what we have to do is, as a variable force is going on, acting on a body, and that is charted at different values of force and different values of displacements are charted in a chart, in a tabular column, and now a graph is plotted. Graph is plotted with the displacement, force along the y-axis and displacement along the x-axis. The graph is made. Graph will be a curved line like this. Curved line like this. Now, what you do is that you have to find the area. That means it is like this. Yeah. So it is like this. You will go on drawing like this. Right. It goes like this. It goes like this. Right? Suppose this is a point A and this is a point B. The body is displaced from a point A to B on a surface in a straight line. Right? And this is a small displacement you take, this is equal to delta x3. Delta x, suppose that the body is moving along the x-axis. Right? Then the force acting on the body is equal to Fx3, you can write. This force acting, that is Fx3. For an interval of displacement delta x3 is a very small value of displacement along the x-axis, for which, for the whole displacement delta x3, we can assume that the force remains a constant. Force remains a constant. Therefore, work done for if this small displacement delta x3 can be given as equal to Fx3 into delta x3. This is a very small value. For very small value of displacement in a certain direction, we can assume the displacement to be constant. Right? So many like this. This is delta x1, this is delta x2, this is delta x3, etc. This is delta xn. All these small segments. So delta x3 into x3. Delta x3 into Fx3 is the area of this much part. In the same way, delta x2 into Fx2 is the area of this much part, because these are rectangles. Area of rectangle is equal to this into this, right? Length into breadth. Like that, when you take the area of all these small segments and all add it together, then we will get the total work done. So the total work done W is equal, I can write Fx1 delta x1 plus Fx2 delta x2 plus Fx3 delta x3 plus etc. Fxn delta xn I can write. This is equal to sigma I is equal to 1 to n. I is equal to 1 to n. F xi delta xi, right? This is not vector I, this is simply I, because I is a quantity that is changing from 1 to n, right? Fxi delta xi. What is the meaning of this? This plus this plus this plus this is equal notated like this. Am I correct? Okay. Then if delta x tends to 0, delta x is very small, that point is very important. In this case, if delta x tends to 0, then n tends to infinity. N tends to infinity. So if delta x, the small displacement produced due to small values of force, then we can say that delta x when tends to 0, then the number of segments becomes equal to infinity. Very small, it becomes so small. In that condition, we can write W, then W is equal to integral A to B, Fx dx we can write. Fx into dx. Dx is very infinitesimally small. So this way also we can write. So this is equal to the area enclosed by the ground. So area enclosed by the graph, I am drawing here like this once again. So this is area enclosed by the graph. So this is equal to A, and this is equal to B, and this area. So you have to just to calculate the area, and this is equal to what done. So force displacement the graph we have to plot when the force is variable, and we wish to calculate the work done by the variable force. What we have to do? We have to plot a displacement. Sorry, force displacement. The graph is calculated, and so the graph is plotted, and the area enclosed by the force displacement graph with respect to the displacement axis, which is the displacement axis. With respect to displacement axis, how much area the variable force and the graph curve is enclosing, that is equal to 1. Right? You calculate the area in meter square and write it as equal to joule. Right? Area enclosed by that is calculated, and it is given by what unit? Joule, you will say, because work done, the unit of work done is joule in the SI system. Remember that unit of work done in the SI system is joule. Joule is equal to 1 Newton into 1 Newton into 1 meter. 1 joule is equal to 1 Newton into 1 meter, right? 1 Newton into 1 meter is equal to 1 joule. But 1 Newton is equal to kg meter per second square. That is, this is equal to kg meter per second square into meter. This is equal to kg meter square second raised to -2. This we also got the standard. This is this unit of work done. Work done is equal to joule. Work done is measured in terms of the unit of energy. That is in joule. 1 joule is equal to 1 Newton into 1 meter. 1 Newton is equal to kg meter per second square into meter. That is equal to kg meter square per second square. So work done is a scalar quantity. How we can understand whether a quantity is scalar or vector? For that we must know about the idea about that physical quantity. That is why in the first topic itself we have started with the physical quantity. So many physical quantities we discussed. Fundamental quantities discussed, derivative quantities discussed. When is a quantity can be a vector quantity, when it can be a scalar quantity, all these things we have discussed, right? So this is about the chapter today. Tomorrow I will come with a new topic of the same lesson. Till then, bye bye. Thank you very much.